Hello everyone, in this video I'll be explaining you the problem alternate jumps, and it was asked in Codechef contest starter 208. So let's go to the problem. So the problem says alternate jumps, there are n lily pads arranged in a line. They are numbered 1 to n from left to right. So a frog is initially standing on lily pad n. The frog loves to jump, so it will perform a sequence of n minus 1 jumps with alternating direction as follows. So first jump to the lily pad, is n minus 1 position to the left of its current position. Okay. Next jump to the lily pad, n minus 2 position to the right of its current position, and then next jump will be to the left, and it is n minus 3 positions. So more formally, it is basically ith in the ith jump, I being from 1 to n minus 1. If I is odd, the frog will jump to the lily pad n minus I position to the left of its current position. So that will make its current position as to be, if let's say if the current position is x, then it will be x minus n minus I. And if I is even, then frog will jump to the lily pad n minus I position to the right of its current position. So when he's moving to the right, so his position will be increased by x plus n minus I. So it can be proven that all the frogs jumps are valid, that is it will always be on one of the lily pads, okay, from 1 to n. So you are given n, can you find the number of the final lily pad the frog will end up at. So they have given test cases, and then for every test case we have integer n. So let's take example and then understand. So in the first example, let's say n given is 2, we have to find what is the final position of the frog. So in the question, what they've said is there are n lily pads, okay, there are n lily pads, and frog starts from nth lily pad. So always, let's say from 1 2 3 up to so on n minus 1, and we have n pads, so our frog will be here at this position initially. And now what they're saying is, in the ith operation, so I, which is from 1 to n, so now when frog is at last position, so he will move n minus 1 distance this way, okay, in the first whenever I is 1, so he'll move this direction. So it is saying left side he'll go n minus basically I steps he'll go, and right side also he'll go n minus I steps forward. So when let's say this position, if you consider it as x, so since he's moving backside, so his position will be decreased by, because he's moving this way, right? It is see increasing order 1 2 3 up till n. So he's moving decreasing side. So whatever current position is there, in that you'll have to subtract n minus I. So this will be the position of the frog, the present position when he moves to the left side. So he'll be moving left side then right side, left side then right side. So it is an alternate way. So whenever this I whatever it starts from, right? So if that I is odd, right? If I is odd, then he'll be moving to the left side. Starting he'll be at the end position when I is 1, so he'll be moving back side. When I is 2, he'll be moving right side. So now let's consider he came at this position, I mean frog came at this position. Now since I was 1, so we moved n minus I, which is n minus 1 distance here. Now in the second operation I will be 2, so he'll be moving n minus 2. So when he move n minus 2 distance, he'll be at this position, right? Because there are if you leave this, so how many terms are there? N minus 1 terms are there, but he'll be moving only n minus 2 distance. So if you take 1 2 3, so here it will be n minus 2, so he'll be moving at this position. So whenever he's at this position, I'm moving right side, his current position is going to be increased by n minus I, next position. So that is asked in the question. And when he's doing this operation, next time he'll move at this position, the next time he'll move n minus 2 position, then he'll come here. So eventually, if you see these two as endpoints, so the frog start from this endpoint, he's moving to this endpoint, then he's moving to lower endpoint, then he's moving to some higher endpoint, like so. Whenever these are the points, so he will be at a position wherein he cannot jump basically neither left side or north side. This will happen only when I is equal to n. So n minus I distance you are moving either right side or left side, right? So when I is n, I mean in the final step, n minus n is 0, so he'll not be moving any distance, so he'll be at one of the position. So if you consider this as one based indexing up till n, so what is the position of the frog in the final place that they're asking? So this is the question problem statement, and let's try to understand some of the examples. So in the first case, they have given two lily pads are there. So you can consider this is lily pad 1 and this is lily pad 2, and initially frog is at here at this position. Okay, so when your I operation will be starting from 1 till n, it will be going. I is from 1 till n, as I said here. Yeah, so when I is 1, so since this is odd, right? I1 means it is odd, I is odd, so he'll be moving left side. When he moves left side, how many distance he'll be moving? N minus I distance he'll be moving. What is n? N is basically 2. What is I1? So one distance he'll be moving left side. So let's say now frog, this place is already dealt, so now your frog is here. When your frog is here, now I is 2. When I is 2, because you'll have to perform from I1 to n. So when I is 2, your n minus I is going to be 2 minus 2, which is 0. So 0 steps will be moving. And since this 2 is even, even means he'll be moving right hand side. Right side he'll be moving. So 0 distance right side he'll be moving, which means basically he'll not be moving. So he'll be at this position only. So as you can see, your frog was here and he came here, and now he is not able to move. So this is the final position of the frog, where like he'll be present when your operations are done from 1 I is equal to 1 to n. So what is this position? This is 1. So in this case you will have to return 1 as the answer. So this was it, and let's try to understand when n is 3. Understanding this problem is important. Solution is like one line. It's very easy. When n is 3, let's say, which means you have 3 pads. 1, 2, 3. You have 3 lily pads. Initially your frog is at this position. Now when you're doing I is equal to 1 operation, so when you're doing I is equal to 1, which means this is odd, he'll be moving left hand side. Frog will be moving left hand side. So how much distance he'll be moving? N minus I, which is basically 3 minus I is 1, 2 distance. So he'll be moving 2 distance left hand side, 1, 2. So right now your frog will be at 1, 2, 3. This place is done. Your frog is here. Now when I is 2, since this is even, evens means your frog will be moving right hand side. When your frog is at this position, now when I is equal to 2, second operation doing, so it is even, he will be moving right hand side. By how many distance? N minus I. What is n? 3. What is I? 2. So by one distance he will be moving right hand side. So now your frog, this is at current position is x, so he will be moving at this position one distance. So your frog is here, and this position was already, your frog was already present, and now this position is also already present. So okay, now this is your frog's current status. When I is equal to 3, this is the last operation, because I is equal to n in this case. So this is 3 means this is odd. If it is odd, your frog should move left hand side. Yeah, your frog should move left hand side. Now by how many distance? N minus n is 3, I is also 3. So 0 distance will be moving. Basically he'll not be moving. So whenever I is equals to n, which means whatever position at which your frog is, that is the final answer. When your n is equals to, I is equals to n. So right now in this case you can see the final position of the frog is 2. So 2 will have to return. So as you can see, in the first case we had to return 1, in the second case we had to return 2. So let's understand one more example, and we will then try to formulate how to form this. Now let's consider n is equal to 4. So in question they have not given, but let me try to solve this. So we have 1 2 3 4. So as you were saying in the two examples, your frog was starting from here. So in the next step he'll be moving this side, okay, and in the next step, since this position is done, like he'll be moving at this position, so your frog will be moving at this position. So your frog came here, and in the now next step he'll be moving at this position. So this is the final position of the frog. When n is 5, we can consider this way also. So your frog initially is here, he'll be moving at this position farthest end. In the next, if you do the way I was doing mathematical calculation, if you do, so this will boil down to the way I'm doing. So frog is here, now he'll be moving at this position. Now he's at this position, he'll be moving second, when here I is equal to 2, basically here it was I is equal to 1. So n minus 2, which is 3 steps, he'll moving 1 2 3, he'll be moving, so he'll move here, okay. So in the next step he'll move here, in the next step he'll move here. So as you can see, this is the final position of the frog. So when n is 5, your answer is 3. Yeah, when n is 5, answer is 3. So how do you solve this? As you can see, we don't have to do the calculations at all. It is just you'll have to keenly observe how should we find this. Let's say when n is 5 only, 1 2 3 4 5 we have. So when n is 5, so your position was 3 only, right? It will be somewhere in the middle. Like your frog is starting from this end, so in the final step it will be in the middle only, right? Whatever you do, it will be in the middle. So when your n is, let's say, 6, 1 2 3 4 5 6, your frog is starting from here, he'll move here, then he'll move here, then he'll move here, then he'll move here, then he'll move here. So now also, since it is starting from here, this is your final position. So this is also middle only, 6 by 3 if you do, sorry, 6 by 2, half I'm taking middle, 6 by 2 if you do, this is 3. And in the odd case also, whenever it is 5, if you do 5 by 2, it is going to be 2, but 2 is not the final one. So what you do is, basically in this n you add +1 and then divide it by 2 you do. So this will give you the answer. So n is 5, so 5 plus 1 is 6, 6 by 2 if you do, that is 3. In this case also, n is 6, 6 plus 1 is 7, 7 by 2 if you do, this is also 3. So basically for a given n, you will have to print n plus 1 by 2. So this will give you the answer. I think you guys understood it. Let's try to code it up. So yeah, they have given test cases. For every test case we have integer n, so we have taken care at this position. Now as I said, you will have to print n plus 1 by 2 and l. So it was just a simple code. Just we need to understand the problem, that's it. Issues. Yeah, it passed. Let's try to submit the code in the online editor. So yeah, it got accepted. So in this way you got to easily solve the problem. So thank you guys for watching the video.